All right, today we're diving into one of the most exciting new frontiers in artificial intelligence, the rise of AI that can actually teach itself.
I mean, let's be honest, modern AI is mind-blowing. It can write code, it can generate incredible art, it can answer questions that would stump most of us. But these incredibly powerful models are all hiding a pretty big secret, a fundamental flaw, really. That's right. For the most part, today's AI is static. Once a model is trained, its knowledge is completely locked in, basically frozen in that moment. So if you want it to learn anything new, you have to scrap it and retrain the whole thing from the ground up. And that has created a massive, massive problem for the entire industry. So yeah, this is what researchers are calling AI's static thinking problem. And it's the core challenge that a whole new wave of innovation is desperately trying to solve. The old way of doing things is called fine-tuning, and it's a bit like having to re-educate a genius all the way from kindergarten just to teach them a new hobby. I mean, think about it. It's wildly expensive, it takes forever, and even after all that, you're still left with a static model that can't adapt on the fly. And when you see them side by side, the difference is just wow. Traditional retraining is slow, it's costly, and it's super rigid. Self-adaptation, on the other hand, we're talking dynamic, efficient, and flexible. It allows an AI to learn in real time. And that brings us to the self-adapting dream. This is the big vision, right? Creating AI that can learn and evolve continuously. Kind of like we do. The coolest part is that the inspiration for this comes straight from our own brains. When you switch from doing, say, a math problem to listening to some music, your brain doesn't have to reboot itself. It just activates different specialized areas. And that is exactly the goal for self-adaptive AI. So this approach really unlocks three huge benefits. First is modularity, letting the AI turn on separate expert skills whenever it needs them. This directly leads to continual learning, which means the AI can pick up new tricks without something called catastrophic forgetting. That's where learning a new skill basically erases an old one. And finally, the whole thing is just way, way more efficient. So, the big question is, how do we actually build this? Well, let's take a look at two really cutting-edge methods that take completely different paths to get to that same dream. Okay, first up, we've got an approach that works from the inside out. It's called Transformer², and it's all about rewiring the model's internal brain circuits, but on the fly. So at its core, Transformer² lets a large language model adjust its own internal wiring, what are called its weight matrices, which kind of define everything it knows, but in real time. This lets it adapt to a brand new task without any of that massive, expensive retraining. Now, here is a fantastic way to think about this. Instead of having to rebuild an entire orchestra just to play a new song, this method is more like a sound engineer. It identifies the most important parts of the model's knowledge, these are called singular values, and it just adjusts their volume using these tiny little expert vectors. It's like it's creating the perfect audio mix for whatever job it's been given. And it pulls this off using a really clever two-pass system. On the first pass, the model takes a look at your prompt and basically asks itself, okay, what kind of job is this? Is this math? Is this creative writing? Is this coding? Then on the second pass, it uses that answer to mix in the exact right expert vectors to generate a specialized, super high-quality response. All right, now for our second method, AdaptRec, which takes the complete opposite approach. Instead of rewiring the model on the inside, it focuses on perfecting the information it gets on the outside. So AdaptRec is built for recommendation systems, things that suggest your next movie or your next song. Its entire goal is to create the perfect, hyper-relevant prompt for the AI by first learning from the behavior of other people who are just like you. And it does this in 3 stages. First, it scans a massive database to find users who might be similar to you. Then, here's the smart part, it uses the AI itself to intelligently filter that list down, picking out only the most useful examples. And finally, it uses all that rich information to build a perfectly tailored, context-aware prompt. Now, a standard prompt, the kind we use now, is incredibly basic. It might just say something like, predict the next movie this user will watch. It gives the AI almost nothing to go on, right? It's flying blind. But now look at the AdaptRec prompt. It is just packed with these useful social signals. It basically says, hey AI, check this out. People with similar tastes to our user watched these movies, and then they chose this movie next.
Now use that knowledge to make a much better prediction. It's a total game changer.
And the proof is right there in the data. On the last FM music dataset, this smart prompting approach improved the accuracy of predicting a user's very next song by over 18% compared to the best method we had before. I mean, that's not just a little bump, that's a massive leap in performance, all from just perfecting the prompt.
So, what happens when we put these two big ideas together? Well, what we're seeing is the dawn of a new era of truly dynamic AI. So let's just recap these two approaches real quick. Transformer² rewires the AI from the inside, like that sound engineer at the mixing board. And AdaptRec perfects the input from the outside, kind of like a smart collaborator who finds the perfect reference points for any task.
2, it's really important to remember that number. These are not competing methods. They are two complementary paths leading to the exact same destination. One is optimizing the AI's internal state, and the other is perfecting its external context. The real magic is going to happen when we start combining these ideas. And together, they give us this really clear vision of the future, a future where AI is no longer frozen in time, but is dynamic, it's efficient, and it can perfectly specialize itself for any task you throw at it, instantly. We are really witnessing a fundamental shift away from static, one-size-fits-all AI towards a more fluid, adaptive intelligence. And that leaves us with one really fascinating question. As AI finally learns to adapt for itself, what impossible challenges will it solve next?